Hello and welcome to this 12th Algorithm Selection and Development lecture in this course, Master in Artificial Intelligence. So in this lecture, we will talk about how to iterate on model development process. And specifically, we will talk about one of the ways, which is to fine tune the hyperparameters. So let us get into iterative development process that requires three things to be done. One, iterate on the model development process by tuning hyperparameters, experimenting with different architectures, incorporating domain designs. And in doing that, you need to know the techniques like regularization we talked about, dropouts, batch normalization, learning rate scheduling that can improve model generalization and performance, and finally monitor and analyze model training and validation metrics to diagnose issues as you go forward and make adjustments accordingly. So let us start to iterate on the model development process by fine tuning the hyperparameters, etc. Right? So, how to iterate on the model development process by fine-tuning hyperparameter, experimenting with different architectures, and incorporating uh, domain knowledge. Any thoughts? See, in this, we to iterate in the development process, we need to do three things as we talked to you just now. One is to fine-tune the hyperparameters. Second, experiment with different architectures, and then incorporate domain knowledge. So the question now is how to iterate on model development process by fine tuning the hyperparameters. Only one of the things that we will talk about in good length, good depth, as actually. So iterating on model development process by fine tuning these hyperparameters that involves a systematic approach. There you can optimize the performance of your machine learning model and what are the steps you can take to fine-tune hyperparameters iteratively. Let's take a look at that. So first thing you need to do is to identify the hyperparameters that are relevant to your model and optimization algorithm. And you have a large number to choose from, common hyperparameters including learning rate optimization that we talked about, batch size, regularization strengths, number of layers in the neural network, number of units per layer, and dropout rates, etc. etc. So you need to define these hyperparameters in the first step. Then you choose a validation strategy to evaluate the performance of different hyperparameters configurations. You will use you can use many hyperparameters in different configurations. So you need a validation strategy. And your options include simple holdout validation, a k-fold cross validation, or more advanced techniques like nested cross validation, etc. So you select a validation strategy with that. Then you select a hyperparameter optimization technique to search the hyperparameter space effectively. And these include, there are various options to search: grid search, random search, Bayesian optimization, genetic algorithms, and many more. And the first four we have already talked to you about as in the earlier lecture. So that's how you choose a hyperparameter optimization technique. Then you choose an initial set of hyperparameters based on intuition, previous experience, or defaults given by the programs. And then you train the model using chosen hyperparameters and evaluate the performance on the validation set. So that's what you do in initial hyperparameter configuration. Then you iterate through the following steps until a stopping criteria is met in iterative optimization. So you do this on iterative optimization where you start by choosing a hyperparameter optimization technique to explore the space and select new hyperparameter configuration. Train the model as we discussed using the selected hyperparameter on the training data Evaluate the model's performance on the validation set using the chosen validation strategy. Analyze the model's performance metrics and compare them to the previous iterations. Adjust the search space, optimization technique, or hyperparameter values based on this analysis and iterate through to optimize. You then define a stopping criteria to determine when to stop the hyperparameter optimization process. Now, this could be reaching a predefined number of iterations, achieving a satisfactory performance threshold, or observing diminishing returns from further optimization. So, you define the stopping criteria. Once the hyperparameter optimization process is complete, you select the model with the best performance on the validation set. And here, optionally, you can evaluate the selected model on a separate test data to estimate the performance on unseen data. And you can do further refinements optionally by additional rounds of hyperparameter optimization or fine tuning to further improve the model's performance. And also you can experiment with different hyperparameter values, optimization techniques, or model architecture to explore alternative configuration. So it's all about exploring, experimentation, and iteration. So by following these steps, you can iteratively fine-tune hyperparameters to optimize the performance of your machine learning model. This iterative approach allows you to systematically explore hyperparameter space, identify optimal configurations, and improve the model's performance over a period of time to find that elusive optimal solution. So what do we do next? Having looked at how to select the hyperparameters, experiment with different architectures, incorporate domain knowledge, we will now look at how do you use techniques like regularization, dropouts, batch normalization, learning and scheduling, etc. for better overall performance of the model. So thank you so much for watching this 12th algorithm selection and development lecture in this course, Master in Artificial Intelligence. I hope you continue to learn new things, continue to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions that I can answer for you. And also download the PDF file to take a look at anything that is of specific interest to you.